So this is the 2018 titration question, okay, and it's to work out the total hardness in a water sample. So let's read the question. The total hardness in a water sample was estimated by titrating 50.0 centimetre cube samples of the water with a standard solution of EDTA, ethylene, diamine, tetraacetic acid. The ions that cause hardness represented by M2+, and the EDTA ions represented by H2, Y2-, react according to the balanced equation. So you're given the balanced equation here, and we note that the molar ratio between the hardness in the water and the EDTA is 1:1. Okay, so highlighting the important facts in the question, right? So the average volume of 0.01 molar EDTA, so that's the concentration of the EDTA solution, was required to react with 50.0 centimetre cubed of the water, was 9.3 centimetre cubed. So we're going to highlight all of those bits of important information and put them into our calculation. Okay, so let's focus on the calculation, which is in part E. So first of all, we're asked to calculate the average number of moles of EDTA used in the titrations, then the number of moles of M2+ ions in the 50.0 centimetre cubed of hard water, then the total hardness of the water expressed in grams per litre of calcium carbonate, so that's the concentration, and then the total hardness of the water expressed as ppms. Okay, and remember 1 ppm is 1 milligram per litre of the calcium carbonate. Okay, so let's set up a table, and we start by writing out our balanced equation, which we have here. Note that the M2+ ions are the hardness in the water, and the H2Y2- is the EDTA. Okay, now so let's write in what we were given in the question. We were told that our average volume, our concentration of the EDTA was 0.01. So we set up this table where we have molar ratio, number of moles, volume in litres, and concentration in moles per litre. So we're told that the concentration of the EDTA solution, we underlined this in the exam paper, was 0.01 molar EDTA, and it said it was required to react with 50 centimetre cubed of the water. So we had a volume of 50 centimetre cubed of the water, and the average titration volume was 9.3 centimetre cubed. Okay, so the first thing we're going to do is we're going to change these volumes into litres, because the volume must be expressed in litres in our calculation. So we're going to divide by 1,000, so that will give me 0.05 litres for my water, and for my EDTA solution, which is in the burette, 0.0093 litres. Okay. Okay, something else I'm just going to do in rough work is I'm just going to work out the relative molecular mass of calcium carbonate. Okay, this is the chemical that causes the hardness. Okay, and we express the total hardness of the water as the amount, the concentration of calcium carbonate. So the relative molecular mass of that is going to be 40 plus 12 from the carbon plus 3 oxygens, 316, so we get 100. Okay, so back to our table now. So the molar ratio between the hardness and the EDTA, so the hardness of the water in the conical flask and the EDTA in the burette, is 1:1. So we'll just write that in, 1:1. Okay, so let's now try and work out how many moles of my EDTA I actually have when I get to the end point of my titration. So how many moles of EDTA do I add into the conical flask in order to fully react with the calcium ions that are in the hard water? Okay, so for that we're going to need a little triangle just to help us. So the not very complicated triangle is going to help us. And if we want to work out number of moles, so if I cover number of moles is going to be volume times concentration. So number of moles is going to be volume times concentration. So for us, we know the volume is 0.0093. Remember, that must be in litres. And my concentration given to me in the question was 0.01. Okay, so when I multiply those, I get a number of moles being 9.3 by 10 to the minus 5 moles. Okay? Alrighty, so that's actually the answer to the first part. I was asked in the first part of section E to calculate the average number of moles of EDTA used in the titration, and we have that here now. It's 9.3 by 10 to the minus 5 moles. Okay, part 2 there is asking for the number of moles of M2 plus. Number of moles of M2 plus in the 50 centimetre cubed sample of hard water. So let's go back to our table. So here we have our 50 centimetre cubed of our water sample, and we know that we've just worked out a moment ago that fully reacted with 9.3 by 10 to the 5 moles of the EDTA. Now, based on my molar ratio, I know there's a reaction ratio there of 1:1. So we have the same number of moles in this titration of each. So if I have 9.3 by 10 to the minus 5 moles of my EDTA, I have the same number of moles. So I'm multiplying by 1 in this instance, okay? So I have 9.3 by 10 to the minus 5 moles of my M2 plus ion. So let's write that in down here. So the answer here is 9.3 by 10 to the minus 5. Don't forget my units are moles. Okay, in part 3, I'm asked to find the total hardness. And we want to express that in grams per litre of calcium carbonate. Okay, so they're my units that I want to express my total hardness in. Okay, so I need to know the concentration of my hardness in the water. So again, using my not very complicated triangle, if I cover up concentration, concentration is the number of moles divided by volume. So concentration is number of moles divided by divided by volume. So the number of moles we just worked out to be 9.3 by 10 to the minus 5 divided by my volume expressed in litres. So 0.05, and when I divide that, I get, we get 1.86 by 10 to the minus 3, and that's in moles per litre. Okay, so that's my concentration in moles per litre. So I'm just going to write that down here for a moment. So my total hardness in terms of concentration in moles per litre is 1.86 by 10 to the minus 3 moles per litre. Now, I want to change that to grams per litre. How do I convert moles to grams? Well, I use another important triangle to help me, the good night Mr. Tom triangle. Okay, so to find the grams, okay, so to find the number of grams, I cover up grams and I have number of moles times relative molecular mass. So what I'm going to do to change this into grams is I'm going to take the number of moles, which I have here, so grams is the number of moles times relative molecular mass. So down here now I have my number of moles, so let's multiply that by the relative molecular mass, which I've already worked out earlier on. Okay, my relative molecular mass of calcium carbonate is 100. So if I multiply by my number of moles times the relative molecular mass, I have a concentration of 0.186 grams per litre of calcium carbonate. Okay. Now the very last part, I'm asked to express the total hardness, okay, as ppms. Okay, so I want to have my concentration now of calcium carbonate expressed as ppm. So what we're doing here is we're converting grams per litre into milligrams per litre, because we know that 1 ppm, 1 part per million concentration unit, is the same as 1 milligram per litre. Okay, so I simply need to convert grams per litre into milligrams per litre, and there are 1000 milligrams per gram. Okay, so let's take our 0.186 grams per litre and multiply that by 1000, and we will have 186 milligrams per litre, okay, of calcium carbonate, which is 186 ppm. Okay, so that's the final calculation on 2018 question 1. Okay, total hardness calculation. Okay.